Welcome to True Projects. In this video, we are going to explain about clustering-based collaborative filtering using an incentivized or penalized user model. Introduction. Given the abundance of content available both online and offline, the project examines the difficulty in recommending appropriate content to people based on their taste. Collaborative filtering (CF), one of the most widely used approaches, has been extended into recommender system to aid users in choosing acceptable information. The two main types of CF techniques are memory-based and model-based CF. The project offers an innovative, quick-to-implement clustering-based CF (CBCF) method that relies on user ratings and an incentivized or penalized user (IPU) paradigm. By carefully utilizing the various preferences among users, CBCF with the IUP model aims to improve recommendations performance such as precision, recall, and F1 score. Objective. The project's objective is to provide an innovative, quickly implementable clustering-based CBCF method that simply uses user ratings and an incentivized or penalized user IPU model. By carefully utilizing the various preferences among users, CBCF with the IPU model aims to improve recommendation performance such as precision, recall, and F1 score. The project's goal is to provide a straightforward clustering-based method that enhances suggestion accuracy without requiring any additional prior knowledge. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Software requirements. In software requirements, we have Python IDLE with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is cluster dataset using spectral clustering. Spectral clustering is a technique used to partition a dataset into groups or clusters based on the similarity between data points. In this step, the dataset of user-item interactions is clustered using spectral clustering. Each user is associated with a cluster, and this clustering is based on factors such as their item preferences, behaviors, or other relevant features. Second module is initialized user-item rating matrix. The user-item rating matrix is a fundamental component of collaborative filtering. It represents users' rating for different items. The matrix is typically sparse since not all users rate all items. This matrix is initialized with the available user ratings and can be used to estimate missing ratings for recommendation. Third module is loop all test items for newer user. For a new user who hasn't provided any ratings yet, the system loops through all the test items without ratings to make recommendations for them. Fourth module is identify cluster to which new user belongs. The new user's attributes or behaviors are analyzed to determine which cluster they belong to. This is based on the results of the spectral clustering performed earlier. Fifth module is calculate cluster rating for new test item. The cluster's average rating for the particular test item is calculated. This rating represents the preference of users within the same cluster for the item. Sixth module is calculate average rating of new test item from user rating matrix. The average rating of the new test item is calculated using the available ratings from users who have already rated the item. This provides an idea of the item's overall appeal. Seventh module is conditional recommendations. If the calculated average rating is greater than a certain threshold alpha, the item is recommended to the new user. If the calculated average value is greater than the threshold beta and the cluster's average rating for the item is greater than the threshold gamma, the item is recommended to the new user. If the above conditions are not met, the item is not recommended and is dropped. For the execution of the project, we need to open the code folder. This is the code folder. This is the Amazon dataset in which we have the Amazon datasets information. Importing this dataset contains the information of product ID, name, ASINs, brand, category, SKU, manufacturer, review date, etc. And this is the model folder. This folder contains pickle and .h files stored, which contains the algorithm information. These pickle and .h files can be loaded into the project code during runtime to utilize the train models. And this is the main code file. This is run.batch file. Instead of executing a project in the command line interface, we have created Windows batch file to execute the project. Double click on run.batch file. this is the graphical user interface which we have created using the Kenter library in Python. Using this GUI, we will interact with the project. Click on Upload Movie Lens dataset to upload the dataset. I am selecting the movies dataset. Open. So here we can see that the dataset is loaded. Now click on Run Spectral Clustering to apply clustering on dataset. In above screen, we have converted all users and ratings into matrix where all column headers are the movie ID and the first column value in all rows is the user ID and remaining column contains ratings for that movie. In last column, we can see cluster ID has 0 or 1 and in above screen, we are displaying few records only. After finding clusters, we have calculated precision, recall and F-score of clustering algorithm. Now click on Run Propose CBCF method to execute CBCF algorithm on above clustering data and to calculate metrics. So here we got the precision, recall, F-score of proposed CBCF. Now click on Run Extension 1 to get its accuracy. So here we got the accurate precision, recall and F-score of extension clustering with CBCF. Now click on Run CNN based clustering to get its accuracy. So here we got the precision, recall, F-score of extension to CNN clustering with CBCF. Now click on Run Extension 3 K-means plus with the BI-LSTM to get its accuracy. So here we got the precision, recall, F-score of extension 3 by LSTM clustering with K-means plus CBCF. Now click on comparison graph. So this is the comparison graph. X-axis represents the different types of algorithm and y-axis represents the performance metrics. And here we can see that each algorithm is having different metrics and each metric is represented with a different color. So here we can see that blue color represents F-score, orange color represents precision, green color represents recall. And from this graph we can conclude that by LSTM and extension with CNN performs well. Now close the graph and the final conclusion of the project is the project's conclusion is that the proposed CBCF method employing the IPU model results in a notable improvement in recall or FN score for a particular level of precision. The project suggested a CBCF technique for a recommender system that properly exploits user preferences in addition to clustering. A constrained optimization issue was specifically framed in the suggested CBCF technique in terms of maximizing recall or alternatively FN score for a certain precision. The application of clustering resulted in not only the division of users into several groups based on the actual rating data and the Pearson correlation coefficient, but also the awarding of incentives or penalties to each item in accordance with the tendency of preferences among users within the same cluster.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe. Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.